Hello everyone, welcome to the 19th lecture in this series. In this lecture, we are going to learn about DQ, which is double-ended queue. In the past two lectures, we have already studied about two implementations of queues, one with array implementation and other being linked list implementation. And we have learnt already that queue is also a linear data structure and it follows the principle of first in, first out. But DQ does not follow this principle and it is a special kind of queue, and the name itself reveals it is double ended. So, in this queue we are capable of adding as well as removing elements from the queue at both the ends, that is insertion and deletion are possible at the front as well as at the rear ends of the queue, and hence we call this queue as double ended queue. And in one of the earlier lectures we have also learnt circular queue, which is used to overcome the limitations which we have with array implementation of queues. You know, with array implementation of queue, usually we define the size of the array ahead, and that is going to be the capacity of the queue. And if in case we reach the maximum capacity of the array, and then in such a situation it is not possible to add more elements into the queue. But with circular queue we learned that by the process of deletion we might have removed some elements of the queue, and such locations will be empty in that array, and once we have reached the maximum limit in that array, those emptied locations can be reused to add up more elements into the queue. So, that is the concept of circular queue. So, for implementing the DQ in this presentation we are going to use a circular queue implementation. So, now let us get into the actual presentation. So, these are the key points which we will be covering up in this lecture. First, we will see an introduction to this double ended queue, then we will see its types, then we will be seeing the abstract data type. So, like any other data structure we have learned before, DQ is also an abstract data type, and so we will be seeing what are all the operations that are permissible in this double ended queue. And then we will be looking at each of these operations in detail. First we will see insertion at front, then at rear, and also we will see how to do deletion at front as well as at the rear positions in this DQ. And also we will be checking, we will have the procedure to check whether the DQ is full or empty, and in one slide we will be talking about the applications of this double ended queue. So, first the introduction. So, like any other data structure, double ended queue is also an abstract data type, which means set of operations are permissible on it. So, here we can add as well as remove elements at both the ends, that is at the front position and from the rear position. We also call this double ended queue as a head tail linked list. So, we actually view this queue to be a linked list, and you know, in a linked list we mark its start position as head and we mark its end position as tail, just because it permits insertion and deletion at both the ends. We call this double ended queue also as a head tail linked list. And as I mentioned before, it does not follow the principle of first in, first out. Of course, we can set up our own priorities and we may decide upon where to insert that element either to the front or to the rear, and that is the reason we say that this double ended queue does not follow the principle of FI FO. In the diagram which you see here, you could see we have a set of elements and we have a pointer named front that marks or points to the first element in the double ended queue, and we have one more pointer named back that points to the last element in the DQ. And you could see here both push and pop, which means insertion and deletion can be done at the last as well as at the first position in this DQ. And now we see what are all the types of this double ended queue. As such, we have two types. One is input restricted DQ and other one is output restricted DQ. In an input restricted DQ, we can do deletion from both the ends, that is at the front and as well as at the rear, but insertion is made only at one end. You know, in a conventional queue we always do insertion at the rear end and we do deletion at the first position, whereas in a input restricted DQ you can do deletions at both the ends and insertion can however be made only at one end only. And in an output restricted DQ you can do insertion at both the ends, but deletion can be made at one end only. So, as you know, always deletion is done at the front position in a conventional queue. So, we mean to say that we do deletion at the front and insertion can however be done at both the ends. Now, we are going to see what are all the operations that are permissible on this DQ, and those set of operations actually make up this DQ abstract data type. And when we talk of this abstract data type, we usually say that the abstract data type of DQ is richer than what we have learned before with stack as well as queues. So, now let us see quickly see what are all the operations that are permissible on a double ended queue. First is add first of E. So, it is an operation. Here it is meant to add a new element E at the beginning of the DQ, and we have an operation called add last of E, which is meant to add a new element to the end of the DQ. Likewise, we can remove elements from the first and the last position by means of these two methods, namely remove first of and remove last of. So, the general principle is whenever we do removal or deletion of an element, we always need to verify whether the queue contains some elements or not. So, we always make a check whether the DQ is empty or not before we proceed to do with remove first or remove last of. And in for all these operations, they are usually get done at a constant amount of time, and so when we say about its time complexity, it is always order of 1. And there are certain other operations which can also be done on a DQ. One is get first of. This method is used to return the first element of the DQ, and here whenever we do get first of, we need to check whether the queue is empty or not, just as we do for deletion of an element from the DQ. And here the point to be noted is that whenever we do get first of, we just fetch the element that is available at the first position of the DQ, but we do not remove it from the DQ. And get last of is used to return the last element of the DQ, and of course, get last of will also throw an error if in case your DQ is empty. So, it is always advisable that when we write code, we have to check whether the DQ is empty or not before we execute these two methods, namely get first of and get last of. And we have a function named size of to return the number of elements available in DQ at the present time. And we have a function named is empty of. So, the name itself reveals it is a Boolean function. So, usually Boolean functions will return either true or false. So, the purpose of this function is to check whether your DQ is empty or not. If empty, it will return true, and if non-empty, it will return a value of false. And just as we saw other methods, for the 4 methods listed in this slide, the time complexity is order of 1. And here in this slide, I have given you some of the operations that can be done on DQ with an example. So, here initially you could see in the first row, we have made a call to the function is empty of, and initially as you see the queue's content is empty. So, it will return a value of true. And now I make a call to the function push front of, by passing a new element A as its input, and as a result this new element A gets added up to the first position in your DQ. Next I make another call to the function push front of with argument as B, and now we want this element B to be in the first position instead of A, and as a result of executing this function, this would be the state of the DQ. B would be in the first position and A would be in the second position. So, this is the only difference of DQ from the conventional queue. So, in conventional queue we learnt always we do insertion at the rear. So, the order of the elements in this case should have been A followed by B, whereas since DQ does not follow the concept of FIFO, we have the flexibility to add the elements wherever we want by invoking appropriate methods. And the third input is push rear of C. So, this element C has to be newly added up to the DQ, but at the last position. So, this would be the state of the DQ. And now we invoke the function pop front of. So, as you know, pop is for removal. We are going to remove the front element or the first element from the DQ. B happens to be the first element, and so it is removed, and so now the DQ is left with just 2 elements. Once again I make a call to the function isEmpty of. Now the queue contains 2 elements, and so this function returns a value of false. And then pop rear of is called. So, you know, pop is for removal. We are supposed to remove the last element from the DQ, and the last element being C is now removed as a result of executing this function. So, again with we have an example. So, here we have a double ended queue with 4 possible operations: push first, push last, pop first and pop last, and we have 2 pointers, namely front and rear, which marks the first and the last positions of the DQ. And here we have just 3 elements in our DQ now, and as you see here, first I do push last of 4. So, the new element is supposed to get added at the last position in your DQ. Then I want to do a pop last, and so the last element from the DQ has to be removed, and so 4 is removed. Again I do a push first of 1. So, the 1 has to be added up in the first position, and then I am supposed to do pop first, and so 1 has to be removed out of this DQ. So, these are the 4 important operations which make up your DQ ADT. So, now let us focus in detail how to do insertion at front. We are going to see this with an algorithm. And as I mentioned before, for the implementation of this DQ, we are using a circular array implementation. So, as you know, the objective of using circular array is to prevent the wastage of space. So, you know, in a queue with array implementation, whenever we delete some elements from the queue, such positions remain empty, and nothing could be done with those positions. And with circular array, it is possible to wrap around and occupy the first few locations that are actually emptied by the DQ operation, right. So, that is the reason why we use circular array for implementing the DQ. So, now you could see here we have an array with 5 locations, and the array index spans from 0 to 4, and by the time we initialize our DQ, we initialize the pointers front and rear with values -1 and 0. And now we begin with the doing insertion at front. First and foremost, whenever we do insertion, we have to check whether the queue is full or not. So, the first step is checking whether the DQ is full or not. Of course, we can have a Boolean function like is full of to check whether we have not exceeded the array's capacity. So, since we are using a circular array for our implementation, in order to check whether your DQ is full, we are actually looking for this, whether your front is 0 and rear is equal to n minus 1. If front is 0, then it means we are containing some elements in the queue starting from the first position, and if rear is equal to n minus 1, then it means even your rear is pointing to the last available position in your queue, and so your queue is full. And alternatively, we can also verify whether front is equal to rear plus 1. So, once front is equivalent to rear plus 1, then also it marks the that we have reached the fullest capacity, and so in such situations we cannot do insertion as we have reached the overflow condition. Otherwise, it means the queue is not full, and so we can very well go ahead with inserting new elements into your DQ. So, if suppose your DQ is empty, then we need to reinitialize front to 0 and add the new element into the front position, that is to the first location of the DQ. If in case front is 0, then we may have to reinitialize front is equivalent to n minus 1, which happens to be the last index. This is the reason why we do for this is when we do when front is 0 means we have some element at the first position and I cannot place the element at the first position. So, instead I look for some space at the last index. So, I have to reinitialize front as front is equivalent to n minus 1. And otherwise, in all other situations, what we need to do is we have to decrease front by 1 and add the new element into array of front. These are the steps which we are supposed to do if you want to insert a new element at the front. So, here we have an example. So, initially we have 5 locations in our DQ and we are having just 3 elements in our DQ at this moment, and my front is pointing to the first position of the array. So, front's value is 0 and rear's value is 2. So, we are checking whether front is free or not. Now, in our case front is already containing an element 7. So, what we do is that we have to reinitialize front. So, in this case we have empty spaces at these locations 3 and 4. So, here what we do is we are reinitializing front to n minus 1. In our case our n minus 1 is 4, as this is because our queue size is 5 and so our n minus 1 is 4. So, front is initialized to 4. Now, we can very well add the new element which is 5 to the location being pointed to by front. So, this is how we do insertion at front in a DQ. So, here we have one more example. So, here you could see front is 0 and front is at 0 and rear is at 2, and we have 3 elements as before, and now I want to add a new element to the front. So, you know, just because your DQ contains an element there, I cannot add the new element at that position. So, I reinitialize front to n minus 1 and I place that new element in the location being pointed to by front. Now, the second operation is how to do insertion at rear. So, this is very common. I hope you know this very well, and you know, always insertion is done at the rear end in a conventional queue, but here we use a circular array implementation. So, whatever steps we adopt inserting a new element in a circular queue, the same steps we are going to follow up here for DQ. As a general rule, whenever we add a new element, we check whether the queue has reached its maximum limit. If the queue is full, then we say that the operation cannot be performed just because there is a overflow. Otherwise, we look for the following conditions. If the queue is empty, then we need to reinitialize rear. So, rear is reinitialized to 0 and the new element is placed at the location or pointer pointed to at the position pointed to by rear. If suppose rear is equivalent to n minus 1, then it means the rear pointer is at the maximum possible or the last location of your DQ, and so I cannot add any more elements at the next location. So, in that case we need to reinitialize rear to 0, that is the first position. And in all other situations what we have to do is every time I should increment rear by 1 and place the new element at that location. So, here let us consider this example. So, here we have the DQ with 3 elements and front at pointing to position 0 and rear being rear pointing to position 2. Now, I want to add a new element at the rear. So, now you see here there are 2 vacant positions in the queue now, and so what we have to do is we have to adopt the third step, that is to increment rear and to place the new element in the position being pointed to by rear. The third operation is how to do deletion at the front position. And by the very principle of queue using arrays, we need to check always whether the queue is empty or not. So, in the same way we first check whether your DQ is empty or not. So, if suppose the DQ is empty, at that situation your front will be having a value of -1, and so thereby we decide the DQ is empty, and so we prompt that deletion operation cannot be performed, and just because it is an underflow situation. And otherwise we can very well delete the element. So, now we are meant to delete the element from the first position. So, if suppose our DQ is containing only one element, then in that case what happens is after the removal of this one element your queue will become empty, and so we are supposed to set our front as well as rear to -1. So, by the time the queue contains one element, usually front and rear will be pointing to the same element. So, front is equal to rear would be true, thereby we will be coming to know that the queue is left with only one element. So, we are removing the one element, and afterwards your front and rear both should be reset to a value of -1. If this condition fails, then it means your queue contains more than one element, and in that case if front is at the last index, if your front is pointing to the last position in your array, then after the removal of the element you need to set front to 0. In all other situations we usually increment front by 1. So, we have an example here, the same DQ with 3 elements. Now, I want to remove the element at the first position. So, here we have to remove this, and so hereafter front should point to the next element which is 3. So, we are incrementing front by 1. So, we are applying the step 5 of this algorithm, and we have front to point to position 1 in this DQ. And the fourth operation is how to do deletion at the rear end of the DQ. And just as we do deletion in queues, first is we check whether the DQ is empty or not. And you know very well, in a DQ if empty, its front pointer would have a value of -1, and once front has a value of -1, we would say deletion cannot be performed and it is an underflow condition. And the second case is we check whether DQ has containing only one element. So, containing one element means your front and rear would be pointing to that one element, and in such a case after removal we will be resetting front as well as rear to have a value of -1. Otherwise, if rear is at the first index, then we will be reinitializing rear to n-1. So, just because we use a circular array implementation, so what is before 0 is n-1 and what is after n-1 is 0, right? That is the way we wrap around. And so, if suppose your rear is at the first index, it means rear is 0, and so we reinitialize rear to n-1. In all other situations we usually decrement rear by 1. So, in our case in this example, you know, rear is pointing to position 2 and that too with element 1, and here only the step 5 applies, and so we decrement rear by 1, and so 1 is removed and now the DQ is left with just 2 elements. And these are the operations on DQ shown here with one more example. So, here what I have emphasized is how to do deletion at the rear end. Here you see front and rear pointing to two different positions, and I just want to remove the last element. So, here also the last step applies, and so I remove the last element and just decrement rear by 1. And this is the way how we check for empty and fullness in a DQ. We have already seen how to decide how to check whether Q is empty. You know very well, when the Q is empty, your front will be having a value of -1, and thereby we will determine the DQ is empty, and if empty we do not proceed with doing a deletion operation. And check full is the method which we normally invoke whenever we add a new element to the DQ. And so this operation checks if your DQ is full or not. And so here we usually make a check whether front is 0 and rear is equal to n minus 1, or front is equal to rear plus 1. If any one of these condition holds, then we decide that our DQ is full. So if DQ is full, we do not proceed with adding more elements into the DQ. And now we see what are all the applications where DQ is actually employed. There are two prominent applications. One is with your web browser's history. You know very well, you might have even checked your history, which actually gives you the list of URLs you have visited day wise and that too time wise. So, for maintaining this history, web browsers actually make use of this double-ended queue, and all the recently visited URLs will be added to the front end of this DQ, and the URLs at the back of the DQ is usually removed after some specified number of operations of insertions at the front. So, as we add more and more URLs to the as more and more URLs are getting added to the front of the DQ, after some point of time URLs will be removed from the back of the DQ. And for task management systems, they usually keep track of orders, and that too it can decide upon the priority of those orders. And so here, just because it is task management, here we mean to manage the tasks. So we are going to fix up the ordering of tasks, as well as we are going to decide upon their priority. So whatever tasks we deem it to be highly important, those are added to the front of the DQ, and tasks with the least priority are generally taken to the back of the DQ. So these are the two prominent applications where DQs are implemented. Apart from that, we can also use DQs for palindrome checking. I hope you might have learnt or done an experiment when you learnt C. So given a string, we need to read it from front as well as from back, and if from both the ends they match, then we say that it is palindrome. Say for instance example, if we consider the string to be Malayalam, so the first and the last position we have M, and in the second from last and the second from first we have A. So that is how we make a check for palindrome, right? And for doing such things, just because DQ gives us the flexibility to access the queue from both the ends, for palindrome checking applications we can make use of this double-ended queue. So to summarize what we have seen so far, double-ended queue, it is also a linear data structure, and why it is called double-ended is that it permits insertion and deletion to be done at both front and rear positions. And we learned that there are two types of double-ended queue. One is input restricted and another one is output restricted. So in input restricted, you can do insertion at one end, but deletion can be done at both the ends, whereas it is vice versa on output restricted, where deletion is done at one end, but insertion is permissible at both the ends, that is front and rear. And we also studied what are all the applications and how your DQ could be implemented. So when we talk of implementation, you could use arrays as well as linked list, And if we think of arrays, then we go with circular array implementation, and if we think of linked list, then it is advisable to go with double linked list, just because we need to access or we need to handle operations at both the ends. We need to have 2 pointers, and that is the reason why we prefer doubly linked list. And we learnt about what are all the applications where this double ended queue is employed. So as we learnt, we could use in web browsers. We could see it is being used in web browsers history, for task scheduling, for palindrome checking, and in most of the applications we have undo redo operations, right? With any editor we will have undo and redo, and for implementing undo and redo, the order in which undo or redo has to be made. For that, to keep track of it, you can use a double ended queue. And in algorithms where sliding window has to be employed, we can use double ended queue to expand or shrink the size of the window. So having studied what a double ended queue is, let us quickly test how far we have understood the concepts of double ended queue. First question is, what is a DQ and how does it differ from a regular queue? You know, regular queue adopts the policy of first in first out, but DQ doesn't adopt it. In regular queue, insertion and deletion is performed at one end only, and whereas in a DQ it is permissible at both the ends. And what are the types of DQ and how do they function? And you know, the types are input restricted and output restricted. So in input restricted, we do insertion at one end and deletion at both the ends, and in the output restricted, it is just the reverse of what we do with input restricted DQ. And what are all the which data structures can be used to implement the DQ? As I said before, we can go with arrays or linked list. If arrays, it is advisable to use circular array, and if linked list, we need to go with double linked list, so that we can handle operation at both the ends. And any two real world applications of DQ, as I said, you can think of undo and redo operations on editor, or you can think of maintenance of history in your web browser. For all these, DQs are getting used. I hope now you have understood the concepts of DQ very well, and with the next lecture we will venture upon a new data structure. Thank you for